Hi, I'm Ashan Uyangoda. Today let's talk about James Webb Space Telescope and its latest findings. In 12th July 2022, the first image of the James Webb Space Telescope was released to the public. It revealed lots of galaxies that we have never seen before. First of all, it is better to know about what is James Webb Space Telescope before going deep down to the findings of this telescope. We are using different types of optical telescopes to see the stars, planets and deep space objects. But it was limited due to different reasons, such as light pollution and atmospheric distractions in the Earth's atmosphere. If we can place optical telescopes in the space, we can get rid of these problems and we can have a clearer view. The James Webb Space Telescope is the latest space telescope that was launched by NASA to the space in 2021 December. Previously, they have launched Hubble Space Telescope to the space. And the difference is that James Webb Space Telescope have lots of new features and better optics than Hubble Space Telescope. Another main difference between James Webb Space Telescope and Hubble Space Telescope is that James Webb Space Telescope is specialized in infrared wavelength, while Hubble Space Telescope is specialized in ultraviolet wavelength. This JWST consists of larger optics. Mainly, it has larger primary mirror compared to Hubble Space Telescope. The Hubble Space Telescope situated in an orbit around our Earth, and it is 570 kilometers above from the Earth's surface. This James Webb Space Telescope is situated in L2 Lagrange point, which is 1.5 million kilometers away from Earth. When satellite or space telescope stays at a Earth-Sun Lagrange point in space, it can stay fixed in the same spot relative to Earth and Sun position, even though it is orbiting around the Sun with the Earth. This is the first image released by James Webb Space Telescope, also known as JWST. This is a near-infrared image of galaxy cluster SMACS 0723. There are thousands of galaxies in this image, and also this image contains an effect called light warping gravitational lensing. The huge objects such as galaxies and dark matter near to Earth behaves like a magnifying glass, and the object behind that appears magnified to the observer. In this image, the objects with diffraction spikes are stars, and red or orange colored fainter galaxies are much further away from us, and other blue colored galaxies are much closer to us. James Webb Space Telescope can see these red-shifted galaxies because it capturing the infrared wavelengths from the wave, and it helps to find the oldest galaxies in the universe. That means looking right back at the beginning of the universe. This image covers only small fraction of the sky, and it is like someone in the ground holding a grain of sand at arm's length and looking at the sky. JWST found the oldest ever galaxy recently within a week of starting the operation. This galaxy is known as GLASS-J13. This is called as GLASS in the beginning of the name because it is from a publicly released JWST dataset which is called GLASS. This dates back to 300 million years after the Big Bang. The previously found oldest galaxy was found by Hubble Space Telescope and it dates back to 400 million years after the Big Bang, and it was known as GNZ11. This is the image of GLASS-J13, and also there was another second galaxy was found in this GLASS dataset by the same researchers, and it dates back to 400 million years. That is called GLASS-J11. According to these researchers, done by using JWST data, it seems that stars form more rapidly than we previously thought in the early universe. According to the size comparison of these findings, these early universe galaxies are very smaller compared to our Milky Way galaxy. GLASS-J13 is about 1600 light years across, and GLASS-J11 is about 2300 light years across, while our Milky Way galaxy is about 100,000 light years across. This is an image of the planet Jupiter, which was taken by James Webb Space Telescope. This is not showing as it would look like to the naked eye. The James Webb Space Telescope taken this image using infrared camera. Different infrared wavelengths have been mapped to different colors to highlight particular features of the image. The orange glow at the poles of the Jupiter represents the Jupiter's auroras. The green color represents thin layer of high altitude haze. The blue color represents the main cloud layer. And finally, the white color represents the tops of storm areas in the Jupiter. This image shows the cosmic cliffs in the Carina Nebula. This is also known as NGC 3324 in the Carina Nebula, and it is a young star-forming region. This is 7600 light years away from us, and it is a gigantic gaseous cavity. The Carina Nebula is one of the brightest nebulas in the sky. This image is taken using near-infrared cameras of JWST. This is the Southern Ring Nebula and also called NGC 3132. This is 2000 light years away from us, and it is a planetary nebula in the constellation Vela. A planetary nebula is a region of cosmic gases and dust produced by cast-off outer layer of a dying red giant star. The next image is the same object taken using mid-infrared instrument of JWST. Incredible amount of information was captured by this instrument, and this revealed a new discovery. As you can see in the middle of the image, there is another star in the left, and it is a hot, dense, white dwarf star. It is in red color in the image. Previously, it was a red giant, and at this stage, it is at the last stage and Now it is white dwarf star. In the previous image, it was clogged by its dust clouds. The blue color star on the right side is stir up the dust clouds ejected by the red colored star, and due to that, the red colored star in the image cannot be seen in the previous image. This is a binary star system. The mid-infrared light can only be observed from space, and it is used to detect objects surrounded by dust cloud. This is the image of Stephan's quintet. It is a visual grouping of 5 galaxies. This is situated in the constellation Pegasus. JWST's mid-infrared instrument captured huge shock waves as one of the galaxies, NGC 7318b, smashes through the cluster. By these red and golden colors, we can see the gas and dust which is heated up in the collision between those galaxies. If you learned something from this video, please like, share and subscribe to my channel.